Three galaxies sit in a single line across millions of light years, and all three are missing the same impossible thing, dark matter. For decades, astronomers assumed every galaxy in the universe carried this invisible mass like a veil, a halo of unseen substance that holds stars together against the forces trying to tear them apart. These three don't have it. DF2, discovered in 2018. DF4, found shortly after. Now DF9, the third and the dimmest, 45 million light-years away, hidden among the stars like a ghost that barely reflects any light. All three aligned, all three barren of the dark matter that should make them possible. The discovery landed this week from Michael Keim, a Yale astrophysics doctoral candidate, and his advisor Peter van Dokkum. They used the Keck Observatory's Cosmic Web Imager, an instrument in Hawaii that peers through the darkness of space with enough precision to catch light from objects 100 times dimmer than anything visible to the naked eye. When they pointed the imager at NGC 1052 DF9, what they found rewrote the assumptions that have governed galaxy science for generations. DF9 weighs around 100 million times what the Sun does. That's not a typo. A galaxy with 100 million solar masses should have 10 times as much dark matter surrounding it. Maybe more. Instead, nothing. The stars inside DF9 move at speeds that contradict every prediction. They should fly apart. They orbit the center of their tiny galaxy with velocities that assume invisible mass holds them in place. That mass isn't there. Before DF2 was discovered in 2018, no one believed this was possible. Dark matter was supposed to be everywhere, not a luxury, but a necessity. The universe as we'd mapped it couldn't work without it. Stars orbited too fast. Galaxies spun too briskly. Light bent around massive invisible clumps we couldn't see directly. To make the math work, to explain what we observed, we needed dark matter. We needed it so badly that some physicists had proposed we were wrong about gravity itself. Maybe Einstein's equations didn't apply on such large scales. Maybe gravity behaved differently when objects were very far apart. Finding DF2 broke that argument wide open. Here was a galaxy without the dark matter halo. Here was proof that dark matter was real. Not an illusion created by misunderstanding gravity, but an actual substance, a physical thing that could be present or absent. The discovery moved dark matter from the theoretical to the concrete. When DF4 appeared, when Keim found DF9, the same pattern held: three galaxies without dark matter, all existing in the same region of space, all aligned in a perfect row. That alignment is the story that changes everything. It's not coincidence. It's a signature. The signature of a cosmic collision so violent that it ripped dark matter away. The leading theory, the one these three galaxies now validate, is called the Bullet Dwarf hypothesis. Imagine two small galaxies colliding. Both are filled with gas and stars. Both have dark matter halos surrounding them. When they smash into each other at high speed, normal matter doesn't pass through. It crashes, slows down, heats up. But dark matter, invisible and barely interactive, keeps moving. The dark matter halos of two colliding galaxies pass straight through each other like ghosts meeting in the dark. The regular matter, the gas and dust and stars, all slam together and lose energy. Some of that regular matter gets torn away entirely. Some galaxies are left stripped, missing the dark matter that once surrounded them. This isn't speculation anymore. The linear arrangement of DF2, DF4, and DF9 traces the path of such a collision. These three weren't born this way. They were altered by an encounter so ancient, it leaves only this ghostly signature. The galaxies sit where they were ejected, their trajectories plotted by the physics of the encounter. Keim and van Dokkum traced those trajectories backward, and the calculations pointed to a single collision event occurring millions of years ago. What this means is profound for how we understand galaxies form. Every model of galaxy formation assumed dark matter halos as the foundation, invisible structures that pull in regular matter and build galaxies around them. But these three galaxies show something else. They show that dark matter can be separated from normal matter. They show that galaxies can survive without it, at least for a time. They show that the universe has mechanisms to strip away dark matter that we never fully appreciated before. The discovery also provides something larger. It's proof that dark matter isn't an alternative gravity, isn't a mistake in our equations. It's a substance, a thing that can be present or absent, that can move independently of regular matter, that can be scattered across space. The fact that DF9 lacks dark matter, while other galaxies have it, proves that dark matter is separate and distinct. It's not Einstein's equations failing us. It's not some modification to gravity that makes galaxies spin faster than we expect. It's real matter, just a kind we can't see. What happens to these galaxies now? They're unstable. Over billions of years, without dark matter to hold them, their stars will eventually drift away. DF9, DF4, DF2, these three ghosts in a line are slowly dissolving. They're temporary structures, the ruins of a collision, existing only because the event happened recently enough, in cosmic terms, that they haven't dispersed. But they will. Eventually, every star in them will escape and dissipate into the wider universe. They're galaxies on a countdown toward invisibility. Keim's work, supported by Van Dokkum's team at Yale, didn't just confirm a theory. It revealed a completely new mechanism at dwarf galaxy scales, a way that the universe can rearrange itself, strip galaxies of their invisible halos, and leave behind walking evidence of cosmic violence written in the positions of three tiny galaxies. The alignment itself is the message. Read them left to right, or top to bottom, as they sit in the image from the Keck Observatory, and you're reading the trajectory of an ancient collision. You're watching the aftermath of an encounter that happened when the universe was younger, when dwarf galaxies were more common, when violence reshaping the cosmos was still unfolding across the void.